Welcome back to our second video examining the differences between Euclidean geometry, which is geometry on a flat surface, and our non-Euclidean geometry, which is spherical geometry. We talked a little bit about the nature of lines, and that lines extend forever in both directions in plane geometry. However, in spherical geometry, lines don't go on forever. They are finite. The line attaches to itself. Now, the interesting thing about lines is that you could place collinear points. For example, on this line, we have 3 collinear points. And when we do that, we have one point that's between the other two, like this one. However, in spherical geometry, we could place a point anywhere along this line, and we could say that any of these points could be between any of the other ones. It appears that this is the between point, but we could just as easily say that, say, this point is between the other two as we wrap around. Or maybe even this point is between the other two. So the concept of betweenness goes away in spherical geometry. The other thing we could think about is the nature of parallel lines. Now, given a point not on a line, you can construct a line parallel to a given line through a given point. That's a basic concept of Euclidean geometry. But in non-Euclidean geometry, if I just draw a second line, pretty much anywhere, they're going to intersect. And if they intersect, they're always going to intersect. There's really no way around it. There's no way to construct parallel lines in spherical geometry. They're always going to intersect somewhere. So we have a line and a point not on a line. There exists one and only one line parallel to that line given through the given point in Euclidean geometry, but not so in non-Euclidean geometry. There are no parallel lines. In the next video, we'll talk a little bit about the nature of triangles within plane geometry and spherical geometry.